Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. The builder of the Jovial Jenny, who is one of our volunteers, Ron Williams, will walk us through the process of designing and building a 2/3 scale flying model. And as an acid test to prove the replication of this iconic aircraft, he actually flew it in. Ladies and gentlemen, Ron Williams.
Good morning. Thank you, Cindy, for the introduction. And let me add my welcome to the Western Museum of Flight. Definitely the best museum on Torrance Airport. I'd also like to point out that the Early Bird Jenny here is both the oldest and newest airplane in this whole museum. It's the oldest because it represents a real Curtiss Jenny from 1915, and nothing else can be older than that. But it's also the newest because it really didn't first fly until 2015, which is probably more recent than all the others as well. So it's unique lots of ways. All right, just a little bit more about who I am. I've been a pilot and flight instructor for around here for a while. I also managed to get to be an A&P mechanic. Got about 4,000 hours, flight safety representative at FAA. I did get my PhD in electrical engineering in University of Illinois, and then came out here and worked for TRW and ultimately Northrop, where I retired. Experimental aircraft, as you can see there. Oops, and those are then a bunch of the other organizations that I hang out with. Okay, so the kinds of things I'm going to be talking about today include the background, kind of how I got started, some of the early days, walking through a lot of the challenges that are inherent in building an experimental aircraft, how I got the appropriate paperwork and approvals from the FAA, a key part of that, then the first flight challenges, and then things that happened since then, and sum up with a little bit about how somebody could start building an experimental aircraft. That was where they wanted to go. So first, what is an Early Bird Jenny? It's basically an open cockpit biplane, as you can see over there. It does qualify under the light sport category. It's a 2/3 scale look-alike of the classic JN4D, which was a very popular training in World War I. Basically, anybody that learned to fly in World War I undoubtedly learned to fly in a Curtiss Jenny. So the one on the left here is a original Curtiss Jenny type of thing. You can see it, and the one on the right is an Early Bird Jenny that was flying at Oshkosh. You can see there's some subtle differences there between it, particularly like the king post. Okay, so this aircraft was actually designed by Dennis Wiley back in 1987. He was an aeronautical engineer and wanted to kind of do his own thing and build something new and different, but liked the looks of the Jenny. It was sold as plans, basically 3D size drawings and 40 pages of notes. So that's what you get when you come there. But it does use modern construction techniques and fabric covering. So although the original Jenny was all wood inside and fabric on the outside, this one has aluminum structure in the wings and steel tubing in the fuselage, but then goes back to the fabric covering on the outside. It ends up that when I first started investigating this, I found the FAA registry had 26 Early Bird Jennies in it. And so I started exploring where could I find them or what could I do more. And it ends up that I was able to find 2 at Oshkosh in 2004 when I first went there. I was lucky enough to find 2 of those. You'll see, those were the pictures I showed you at the very title slide. I found out there were 2 in Southern Ohio. And I go back and visit my family in Southern Ohio, so I dug deeper and found out who had them and managed to meet up with a guy near Cincinnati. And that was this airplane, and asked if I could go flying with him. I figured if I'm going to build one, I ought to find out what it's like to fly it. Now, it also ends up that there was a guy out here at Gino that built one. He was flying it for a while, but then donated it to Marchfield Air Museum. So just a little bit of the technical details here. The engine was a 3-cylinder Suzuki. It came out of a Geo Metro, for anybody who might remember that thing. It ends up being a relatively lightweight, 60, 65 horsepower kind of thing. It is water-cooled, but it uses just regular automotive gas. That's kind of nice. You can see the plane here isn't very big, 28-foot things. Gross weight's under 1,000 pounds, and that's a key thing because that means that it really responds to the air currents a lot more than bigger airplanes do, and it tends to go through the air a little bit like this. A cruise speed is in the 60 to 70 mile an hour, so that also makes it a little bit unique from the other airplanes. Everything out in this thing strove to be 600 mile an hour. I strive to do 60 mile an hour. And the takeoff roll is not vertical takeoff and landing like the new modern electric aircraft that are talked about, but it is still only a few hundred feet either way. Now, how did I get started? I guess the answer is I didn't really go looking for an airplane or a project like this, but I did join EAA Chapter 96 in Compton a while back and found out that they had a group project that they were working on where somebody had donated a fuselage and an engine, and they were wanting to see if Chapter might get together and cooperatively build this airplane. So I kind of got started in that in April 2002, and the more I got involved in the puzzle, the more addicted I got. That's kind of the nature of aircraft building, is the people that are really into it tend to get addicted some. And I'm not sure it's because of me or in spite of me, but after some years, everybody else faded away, and I was left holding all the parts, so to speak. But it also provided an opportunity for kids to learn things, and we had a family that joined us there at EA, and you'll see them in a moment. Now, so I needed a building space, of course, and so I had a spot at the EA hangar in Compton. And so I pulled together a toolbox and a table or workspace, stuff like that, and I had this folding table I thought I could build things on and stuff like that. Fortunately, an experienced aircraft builder came back and said, no, Ron, you don't get it. You need a real aircraft wing table. He showed me then how to build one like this. It's really sturdy. You make sure it's nice and level. You make sure that the edges are truly perpendicular, square, things like that. Because what it ends up is, as you build the parts of the wing, you align them with the table. You can see on the left side there's a tube of 6 standing up that's clamped on firmly. You stick the struts into those. You stick spars into that. You clamp to that. You use the leading edge of the table then to align the leading edge. And so the whole wing then becomes nice and square and straight, which is obviously key to building an airplane. You then can put in the ribs you see here. You can see the aluminum tubing, the front and back. And then after a number of more steps, you put a leading edge that's aluminum that's shaped to fit that. And then here were the kids that I had helping me. They were bright and interested in what was going on, so I showed them how to drill holes and how to place clecos. Those little clamps that you see along the picture there are clecos. And then how to install rivets. And again, this does not use the pull rivets, the driven rivets that other airplanes use. It just uses pop rivets, as they're called, or pulled rivets, so that makes it a lot easier, but suitable for this kind of aircraft. Now, after I got the wings built and the fuselage, I laid it out on the floor, hooked the wings up to the fuselage, and here was the first real test. I measured from the tip of the wing to the tip of the tail, and I did that on both wings. I was elated to find out the two were within a 16th inch. So that meant that my table had really done well. You really wouldn't want to fly around an airplane, right, with one wing forward and one wing back. You know, that wouldn't be good. So this was nice to know that things were working well. Now, move ahead a little bit. In July of 2007, I had some other milestones, and that I managed to pull the fuselage out of the hangar. I attached the wings to it and put the struts in. And you might notice I have a gas can and some other supports that are propping the wings up because they weren't really self-supported at the time. But this, I could really see all 4 wings on there and begin to look like this really might just become a real airplane. And the kids got to see that, and they'd grown up and gotten a bit older, you can see in the process. Unfortunately, by the time I spent more and more years on this, they had actually grown up and moved out of town and were long gone before I could give them a ride. But I had many challenges along the way. One of the things that is that the plans were very detailed about how to build a wing, and that's important. You got to have that plan form just right. But where it came to the front of the airplane, it kind of had a big arrow that said, place engine here. And the rest you kind of had to figure out for yourself. So what's a good engineer do? You know, I went around and looked under the cowling of every other airplane I could find on the airport and looked at how does an engine mount work and look. And as any mechanical engineer might recognize, the answer is you use triangles. Because if you put triangles everywhere, triangles are a really strong construction technique. So the other thing you want to do is prototype and try things out. So like in the left picture here, I went and bought some PVC pipe. I could cut it up, I could glue it together, I could put it in place, I could see, hey, is this gonna work? Now it wouldn't hold the engine, but I could suspend the engine with an engine hoist and see if it's gonna fit. So that's what I would do and keep adjusting it like on the right until it seems to do what it needs to do. Then I also realized, well, there's a co-pilot's feet up in there and a bunch of other things. I really needed a firewall to see how that fits and does the engine fit around the firewall. And I happen to have some red cardboard, so it seemed like, hey, that'd make a good firewall. So I put that in there and taped it in place to see how that's going to fit. And ultimately then, again, I could lower the engine in and say, does it clear everything I need? Does that work? And once I got to work, that's pretty good. The other thing I realized, well, that pipe was a little bit too big for an accurate representation, so I switched to half-inch wood dowel. But again, I still could cut, glue, etc., fit that all in there and got the engine to fit nicely. So I said, okay, now I know what it should look like. But now the question is, how do you convert that to steel tubing, right? So the answer is you build a jig. A lot of answers. A jig means hold things steady in position, right? So this is the front of the airplane. I put these 1x2 strips in, and it holds the two rails at the bottom of the engine mount, which are the most crucial ones for holding the engine. Then I could take apart the other pieces of the engine mount and know those two are still there. And in fact, I could gradually take those dowels out. I could put a piece of steel tubing in and replace each of the pieces individually and then weld it in place. And so continue on. Now it's got the steel tubing in place for certain parts of it. And then afterwards, I had it all tacked together. There was the engine mount. And so then I could take it back to the airplane and finish welding in all around the corners, so to speak. And there's what it looks like then, complete with my prototype firewall. And again, could hang the engine in there and see that it all fits just right. So now there's another challenge. This engine has 3 cylinders, had an exhaust coming off the side, but no muffler or exhausting kind of thing. And you go around and you look at cars, their mufflers are gigantic and heavy, right? Just not suitable for an airplane at all. So again, well, how do I find a muffler? So I went around, I'm looking things like motorcycles have small mufflers. So I went around to motorcycle shops and was all looking underneath the motorcycles, and the salesman would come over and say, well, you know, what kind of motorcycle do I have? And I said, none. He says, well, what kind is it you want? I said, none. He said, why are you in here looking at my motorcycles, right? And I said, because I'm building an airplane. I usually got to come a blank look at that point, but I learned some things from it. But I still had the problem, I didn't find a muffler I liked. So I did a lot of internet research, you know, hunting and searching for mufflers, and I couldn't find anything that was even hardly suitable. And finally, I'm looking through one of the EA magazines, and there's this little article in there about this guy that is flying young eagles. Well, I do that too, so I could relate to that. But it ends up that he was president of a company called Stealth Mufflers. Well, I figured that guy surely knows what mufflers are existing, right? And I got a bit of his name and a company, so I hunted him up and found it. I called the phone number I could have, and the president answers the phone. Well, that's a good sign right there, right? So I talked to him and explained to him I'm looking for a muffler for a home-built airplane, and I'm using it for young eagles and stuff. He could relate to that, so we got on real well. And I described to him, you know, I need one about this big and about this long, just straight through. And he said, well, yeah, that makes sense, but I don't know about that. And I said, well, can you give me any ideas where to go look for other companies or something else I could find? And he kind of said, well, you know, there might be some place in Europe, but I don't remember any company names or anything else. And I said, well, you know, any other ideas at all? And he kind of said, well, what size do you want again? And I said, well, you know, about 4 inches diameter, about, you know, 18 inches long. He says, you know, I've got one sort of like that right here beside my desk. I went, wow, read that, you know, tell me what on it, what brand is it, what model, whatever. And it'd be great, right? He says, you know, there's not a mark on it. I'm going, oh no, what can I do with this, right? And finally he says, you know, I'll tell you what, I'll send it to it, try it, you can try it and see if it works. Okay, so that's the kind of miracles you have in EAA, right? Just somebody opts and sends you something. Well, I got it, it was a perfect fit, just exactly what I needed. The one thing that was a little bit curious is it had a clear plastic external. I thought, well, I'm not sure I've ever seen a muffler with clear plastic, but okay, I'll try it for a while. Okay, so now then I said, well, I've got a muffler, and I need to attach 3-cylinder exhaust ports to a muffler. So clearly I need some kind of a thing like this. What do? Well, again, prototype it. So I went and I found some PVC pipe, there were elbows, and I kind of cut and glued those up until I found something that was sort of like the upper right. And I said, well, obviously plastic isn't going to work, so okay, go buy some 4130 steel tubing. That's kind of the standard thing you can shape and weld and stuff. And so now then, how do I get an elbow out of something like 1.5 inch steel tubing? Well, who does that? How about muffler shops, right? So I went to a local muffler shop and took them in some straight pieces and said, hey, could you bend 3 of these into elbows for me? He says, well, yeah, I guess my equipment will do that kind of thing. So, okay, so he bent me 3 little elbows. That was great. So I get done. I said, you know, thank you very much. How much do I owe you, right? He says, you know, I don't know. Just get out of here. So, okay, thank you, right? Well, then I also had to make a template because, you know, if you weld things, you might know things tend to shift and bend and twist. And I had to have it match up the engine exactly right. So I had to build an aluminum plate that could match to, and then I could put that on and weld it up. So that was the final stage and got the thing lined up with the engine and worked on the muffler, so that was success. Now then, I had to get air into the engine, right? And the original car engine is made to have an air intake kind of sticking up in the air. And I said, well, that looks good for hot rods, but that's not what I want on an airplane, having an intake stick up there. So I figured I wanted to have that intake inside the cowling if I could, but I needed to kind of bend the airflow. So I kind of go to a friend, how do I do this? He says, well, fiberglass. He says, you basically build a mold out of styrofoam, and you cover it with fiberglass and let it set up, and that's what this light colored thing is on here. And then again, a prototype, I didn't know what filter I really wanted yet, so I had a piece of cardboard and see if it fit and got that, so that was a good start. And I also had to have another part of the cooling, I needed some radiator. Well, original Jenny, as you probably saw, has these great big heavy radiators like that, and I looked to try and make something like that, but I realized that was in the same plane as my gear reduction, and I was going to have to cut a hole about this big out of a radiator that big. That wasn't going to work. So I looked around, well, where else can you find small radiators? It ends up that heater cores in a car is nothing but a small radiator. So I managed to go scrounge a couple of heater cores, you see them here, and plumb those things up. And by the way, one of those fittings in there I had to have was originally used on a B-25. So I thought that was kind of neat. And so then on the lower right, here's the kind of my mock-up of the radiator. Again, fiberglass for the frame, some wire mesh on the front, and I could put these radiators behind it that make it look a little like a Jenny. But any motor coolant-supported engine has to have an overflow tank, right? So I needed to put an overflow tank, and there wasn't many spaces in here, so I kind of had to pick what you see here in the upper left corner of that shell, but it was an oddball shape. So I can fabricate some aluminum thing to fit in that corner. But wait a minute, I've learned how to weld steel, I haven't learned how to weld aluminum yet. Another project, go learn some more, and so this is what I did then to build up that overflow tank. Well, then also you need what? Fuel and electrical to an engine, right? So I had to hook up a fuel system. You can see on the lower right of this picture, there's a little fuel pump in there. Fortunately, since it's an automotive engine, a fuel pump, I get an automotive version of that for fuel injection and get that rigged up. Now, this engine also came with a fuel control computer, but it had a tangle of wires and a bunch of sensors, and I didn't like that mess too well. So I kind of cut that all apart and said, well, where do the sensors need to be on the engine? How do I get the wires from there to back behind the firewall? And kind of laid out a whole new scheme. So I did that and mounted this on the firewall. And then you can see on the far right picture, I also needed some relays in line. And I'm kind of thinking, this is a car ignition. It doesn't have a lot of redundancies, no dual magnetos or any that kind of stuff. So I need to think thoughtful about that. And I realized the relays that were in this system were probably the least reliable thing in the whole part. And I really wouldn't want my fuel pump to be disconnected or cut off on me while I'm flying. That'd ruin your day. So I figured, I'll just take pairs of relays, put them in parallel, because indeed, if either one of them fails, the other one can continue to work. So that's what I did here on the firewall you can see on the right. And then, of course, had to have a battery and some fuses and things like that, and so got that all worked in. So now then, it's become August of 2012, and I finally have an engine mounted on the fuselage. I can add gas, coolant, and oil to it. And turn the key, and wonderfully started right up. So I was really happy about that. So now I have a working engine. And move on a few more years, and now I can put the wings back on. And if you notice all the bracing wires between the wings, those are key, because the wood struts keep the wings apart, but you need something to pull them together. And it ends up, as you'll notice on this, the wings by themselves, before you have them rigged up, are just kind of loose like a noodle, just flopping around. You put all these braces and wires in there, and the whole thing just becomes rock solid. This is my friend Carl, so he was helping me out, and so I got out, and I was able to do a first taxi in December 2012. I wasn't too worried about lifting off, because I didn't have much lift with no fabric on there, but I did find there was lots of drag, and I actually needed more power to taxi upwind than I needed to taxi downwind. I also realized, if I'm taxiing around an airport, I really need to talk on the radio and let people know what I'm doing, right? So they see them and can help avoid me or whatever. It's like, I don't have an N number yet or a name or anything else, so what do I call myself? And finally I realized, I'm just going to broadcast that I'm Naked Jenny, and I'll bet everybody can figure out who I am. All right, so the front engine panel, I decided to mock up some wood and bought some instruments and put that in there, very basic kinds of things, airspeed, altimeter, compass and tachometer. And I thought, okay, how do I do a fuel gauge? Well, the fuel tank is right in front of this. So I figured, well, if I just put a piece of clear tubing from the top of the tank to the bottom of the tank, the level on that tubing is going to always match the level in the tank, right? Can't get any simpler than that. Perfect fuel gauge, right? One thing I didn't account for, the place the engine draws fuel is right near the bottom edge of that. You know what happens when you draw fuel from that? The tubing level goes right to the bottom immediately. So, okay, well, one more failure for experiment, and you have to try it out. And it ends up I had to go out and kind of buy a standard fuel gauge and mount it at the bottom of the tank. Now, the back panel was a different challenge. The problem here was I only had about 4 inches of clearance between this panel and the front seat. And all the other kind of instruments and stuff that I had just wouldn't fit in that narrow of a clearance. And so I had a bit of a problem for a while. And I was hunting around, and I finally found out there was a company called MGL that was actually right here at Torrance that had this thing. It was a glass panel. It was made for little fancier airplanes than mine. But it allowed me to do all the engine gauges, all the navigation, all the attitude kinds of stuff, comm control, transponder control, all in a panel that was only that deep. Fit right in there, and it was lighter than any of the other stuff. So it ended up being a really good solution. And I figured, you know, this is what Mr. Curtis would have done if he could have. But it did require a little bit extra because it has a little computer to go with it and some other wiring. So I put a little deck right behind the pilot's seat, and if you look down there, you can see that. And so there's the computer, transponder, and ELT and things like that that I needed, mainly because I'm flying in this area. The guy I flew with in Cincinnati, he didn't use any of those kinds of things. He figured he didn't want to be seen on the radar anyway. But for LA, you really do want to be seen on the radar. But I still had some other challenges. I wanted these nice, cool-looking louvers on the side, but I found out you couldn't just go out and buy those kinds of things. There wasn't even any shops around that would make it. So, well, I got to go figure out how to do that myself. So it ends up that I figured out how to lay out some 1-inch square aluminum tube, use a vertical mill to cut some grooves in it, stack them up, and use a air hammer to pound them in, and came out looking pretty good. But my radiators weren't quite done yet. I realized I also needed to force some air into them, because one of the first things I did was hook them up, and I wasn't getting good cooling. So I put some little tufts of yarn out on the front and ran the engine and did a little video camera. You know, all the tufts of yarn were pointing forward towards the prop, not towards the radiator. Figured that's why it's not cooling well. So I had to do some things like put some aluminum around to funnel the air in better, and ultimately I had to put fans on the back to suck the air through those things. And finally got those things in, and so that looked like that was going to work a little better. So now then come to about 2014, so I've been working at it 10, 12 years already, and it's beginning to look like a pretty complete airplane. One of my biggest fears was if I put the fabric on here and I realized I need to put one more tab right there, it's going to be a real problem. So I said, okay, I'm going to drive this thing around the airport and really test it out and try everything I can possibly exercise before I put the fabric on. So that's what I did, and Naked Jenny drove all around Compton a bunch. Well, now the next step was backwards. Why? Well, one of the things I learned was you put these things together and take it apart, put it together, take it apart, as you do in prototype kind of stuff, right? I was literally wearing out some of the nuts and bolts. And I wanted to make sure I had new aircraft quality hardware everywhere in the aircraft when it really starts to fly. Meanwhile, also the welding and everything else, I dinged the paint and messed up the stuff, and some pieces were beginning to rust after all those years, and it really wasn't looking too good. So I decided the right answer was completely strip it down again to every last piece, and then go through, sandblast and repaint, or reprime and repaint every part and piece, throw away all the hardware I'd used before, fasteners, and put all new aircraft grade nuts and bolts in there. So that's what I did. And see here you can see the fuselage is getting sandblasted and primed. That worked out. Another challenge along the way. One of the things I noticed was as I was taxiing around the airport, the compass tended to point every different direction but north. And, you know, a compass isn't that complicated. So I took it apart, and while I had it here, I took a little hiking compass and started moving it around here, and I found that needle just swung and jumped all different places. It's like, well, what's with this, right? And finally I noticed that each place there was a tab, there was a magnetic hotspot. And it dawned on me what the problem is. One of the typical little tricks when you're welding is to put two things together and use a magnet between them to hold it while you weld. Well, if you think about it, you heat this metal steel up with a magnet there and you cool it back down. That's how you magnetize something. So I'd unintentionally magnetized every one of these little tabs around there. So now how do I undo that, right? Well, I tried various kinds of things and coils, and nothing particularly worked. And so again, being an EAA, you go around and you ask all your friends, how do I get rid of unwanted magnetism? And somebody says, well, you remember old TVs had a coil on the back that did a decalcing, right? I said, yeah, right. So I asked around, and sure enough, one of the old timers had a decalcing ring. It looks like that black thing in there. So I hooked that up, put it in there, moved it around gradually, and I was able to get rid of all the excess magnetization. So I went ahead, got it up on its gear, put the floorboard in, got the rudder pedals and brakes and stuff like that in there, and continued assembling it. And things are going a lot faster at this time, because it's not my first time now. I had details like the tail wheel steering I still had to figure out, and I couldn't find a spring like I wanted, so I had to design and make my own spring. Did that. And now it's about time to really cover things. So I hang the wings up on the wall, and I got the fuselage spread across the floor, and this is Dacron fabric. Although it's a little bit special, it's not quite what you get in a fabric store, because this has no sizing in it, and it's not been stretched or not been shrunk yet. All right? But you buy that, it's called Superflight. So you lay it on there. And indeed, if you notice, there's kind of a turquoise ring around all this. You put this stuff called EcoBond on it. It becomes sort of like a sticky, almost not really gluey, but a little bit sticky. You glue that on there, let it dry slightly, and then just rub the fabric on it, and it'll stick and hold. Then you let it dry for a day, and then it's really firm. Then you can go back and work it however you like. So I did that on the fuselage. And of course, had to do tail pieces, and these you can see are a little further along, and that they have some of the primer on it. And those little blue dots are where I had the rib stitching that was done. And this is one thing that didn't work the right first time. I had to undo it, but fortunately on the tail it was not much rework. And that's called rib lacing. So now then I take the fuselage and I hang it back up on the wall and work on the wings. You can see they're on a stand. One of the other things I discovered along the way is it's really hard to work on something when it's really big and bulky and you can't move it around, especially if you're the only one there. But I realized that if I put a tubing stand on each end with a rotisserie effect, I could rotate the wing. It was a lot easier to work on. So that really worked out well. So then here's another example. I tipped it the other way. Here's fabric put on here. You can again see the Eco bond around the edges. You put the fabric on just loosely, it's good enough. You start wrapping it in place, and then you start using ironing. One step first. You also have to put in things like anti-chafes. You put cloth tape on anywhere there's a metal edge that might rub on the fabric, because you don't want to rub through the fabric. You have to put bracing on the ribs and lots of little things like that. You fill all those details in there. And then you put the rest of the fabric on and you start shrinking it. And it ends up that you just use a regular steam iron. I had to steal one from Vicky. But then I calibrated it at 250, 300, and 350. Because 250 is just a little bit of shrinking down, gets it in rough shape, but it doesn't work enough on the corners. You can see those upper corners are pretty steep curves, so I had to shrink a lot to get around those. So then 300 does that, and then finally wrap it up a little bit of 350. The temperature is important because at 400, the stuff melts. Don't want to go there. So basically, I got it all tied in. And by the way, how do you learn to fabric cover an airplane? You go take a weekend course. Of course. EAA offers weekend courses in electrical systems, in fabric covering, in painting. So I just anytime you need, go take a weekend class, then you come home and you practice. You start out with some small pieces, you put fabric on it, glue it on, try it out, see how it works, how you can iron it, and then you think you got that right, then you go to the real airplane and do it more. That's why it takes 15 years. Okay, so then you also have to do rib stitching in here, and it's a little hard to say, but there's some blue streaks through here. Those were alignments for the rib stitching. And then you put additional reinforcement and doilies and tapes over it. You might see those round things. Why would I put round things in there? It's like, well, planning ahead, someday I'm going to need to get inside that wing for something or another. And I really don't want to go cutting a hole in the fabric. So what you do is you find the proper spot, you take a plastic ring, and you glue it on the fabric, and then put a fabric reinforcement over top of it and glue that on. Then later, you can go back and cut out to the center of that, and the plastic ring and everything else will hold it in place. So little tricks like that allow you future maintenance. So now then, you have to start priming it. And the first thing is you put on something called EcoFill. This is a brushed-on primer, this dull gray, because the one downside of the Dacron fabric is it does not last long in ultraviolet, like sunlight. So you get this filler that has heavy aluminum chips in it. And you rub that in, and then paint on additional cross coats, so a nice thick layer on there, and it really protects the linen thoroughly. But now then, it's gray. You can't exactly paint nice yellow or something else on it. So you have to go back and paint again with a prime coat of white. So again, this is where I had to learn how to spray paint and learn there. And a rotisserie is really helpful because now then I can just turn it whichever way I want. Because I learned quickly that for spray painting, you always want to be painting on a horizontal surface. You don't want to have to try and paint down or paint up. So with a rotisserie, I could just turn it so every surface I had was vertical and allowed the painting to go nicely. And ultimately then I knew I wanted yellow. So I started spray painting yellow and took numerous coats of that. You put it on very thin layers and build it up. And I had the wing covered. So now then I put the wings back up on the wall again and bring down the fuselage and put it on the rotisserie and start doing it. So now I'm putting the filler on that and then ultimately the primer and then do it with the olive drab. You can see how it works there again to go around on the rotisserie and being a key thing. And I also then realized that my steel tubing on the exhaust was going to corrode out really fast if you just had raw tubing. So again, how do other people do this? And I found the typical thing that race car drivers do is put on a ceramic coating. And it ends up being a company in South LA that you just give them the part relatively cheap and they soak it and dip it and cook it and ceramic coating. So then it comes back out and it doesn't corrode. But I had other painting details like that outside of the fake radiator needed to be painted a nice color of bronze. And some of those cover plates and stuff I needed, so I did all those kinds of things. And finally, I'm now back to assembly. So I put the center section up on the fuselage, and I got all the wiring kind of hanging there in place where I'm going to need it. Continue with that. And finally, late one night, it looked like a real airplane, and I kind of ran out of time and ran out of things to do on that part, so I declared victory. And next day, I went back and pulled it out in the sunlight for the first time. So that was a neat day. And then I now have it actually functional. So again, I can taxi around the airport. But meanwhile, I'd actually gone to the FAA and figured out what kind of an N number I could use. And basically, you just go to the FAA website. And if the N number is not in use, you can request it. So I hunted for different kinds of things that might be nice. And I finally realized, well, 1915 J, or Juliet, was available. I figured, well, okay, Jennies were created about that time frame. That's close enough. I'll go for that. So I made it 1915 Juliet. Now, I've got an airplane that ought to fly, but now I have to make sure the FAA agrees I'm legal. So you have to go through and work with them, a bunch of bureaucratic and paperwork, of course. Fortunately, there's two things. There's a step-by-step certification guide from the EAA, and FAA has an aviation circular that tell you everything you need to do. So I do that. I have to reserve the number. I have to submit an aircraft registration application and $5. You have to then have an affidavit of ownership. I kind of chuckled at this one. I had to have it notarized. I had to prove that I was the owner of this thing I just built. And so then I also finally got back the aircraft registration, so I had a legal N number. And I had to pick a flight test airport because the one main rule the FAA has for experimental first flights is don't do it over a congested area with a lot of houses. Well, that makes a lot of sense, right? You just don't want to be flying over houses on something you've never flown before. So I decided that Chino was the area nearby, relatively nearby, the least traffic compared to something like Camarillo or whatever, so I did that. And then I had to negotiate where the flight test area was. And the first one they gave me was even further away, and I explained to them that I was going to take a half-hour flight to get there and a half-hour flight to get back at 60 miles an hour, and that wasn't going to work, so they allowed me to negotiate into using Lake Matthews. I also had to find an inspector. The way this works for experimental aircraft is the FAA doesn't do it themselves, but they nominate or they designate a designated airworthiness representative. So you call around, you find like this, and he's the one that would then come inspect the airplane and do it. Now, most people are thinking, does he really inspect the airplane to see, is it going to fly? No, what he really does, he inspects your paperwork, and he kind of looks at the quality of your workmanship to give you a caution if he thinks you're not going to be able to do it. So then he asked for more paperwork. So I had to do all these kinds of things, drawings, weight and balance, and letters and kinds of things. And he agreed, and so we set a date of December 18th, 2015 to have the do an inspection at Chino. Now this was a big deal because this is the first time in 15 years that I've actually had a real deadline. Being all kinds of deadlines at work, I made efforts. I'm not going to have deadlines on building this Jenny. I'm just going to do it whenever I feel like it, have a good time, that kind of thing, right? And at first I was working Northwest, so I spent just Saturdays. And then later after I retired, I got to spend some more days on it. But it was taking a lot of time, and it was going to take a while that way. And now I had a real deadline. I had to have this thing working in place, or have it all assembled and in place, ready for the inspection, December 18th. So I called up the EA chapter in Chino, and I talked to them some months back. They said, I'm going to need a hangar out there. And they said, okay, fine, we've got a builder's area. We can do that, so great. So I called them up and says, okay, here's the date. I'm going to be out there on Monday. They kind of went, uh-oh. The guy that was supposed to move out didn't. Their hangar's full. I can't use it. So now I'm kind of desperate. I need a hangar on zero notice. And I called everybody I could possibly know or find in Chino, and there are no hangars available. And I'm getting rather panicked because I got a deadline and no place to go, right? And I literally call around over the weekend, and I have 1 week possibility. But on Monday morning, I got the thing on the trailer, and I'm headed for Chino. I figure if I'm going to have to drive up and down the roads and just beg and ask every Chino or hangar I can come to. But I do get a call as I get out there from a guy. He says he thinks he found a hangar for me. So great. So I get out there, and the place is Chino Aviation. I pull up to them, and their hangar is full. It's a maintenance shop. So it's like, well, no, that's not going to work. Okay, Andy, what's the next idea? He says, well, follow me. So I get in my car, the trailer, and we start driving around the perimeter road of the airport. I have no clue where we're going because I'm not familiar with everything. We get all the way around to the far south side of Chino Airport, and we come to this. And I said, you got to be kidding. I said, I don't think I'm going to work well with a bunch of big Gulf Streams, etc. But we go into the owner here, and I talk to him, because remember, I'm really, really desperate. He says, sure, no problem, we'll fit you in. I went, okay. He says, yeah, that corner right over there. So I back over in that corner and unload the plane and start putting it back together. And I thought, well, no, I better complete it. That wouldn't fly too well. So I keep going, and sure enough, I got a little plane there. And you can see it's kind of sitting in the corner. If you look carefully in the upper left, there's something hanging above it. That is a large jet engine. And I thought, my first thought is, I hope they tied it up to the ceiling really well, because I surely wouldn't want an earthquake to drop that on my little tiny plane. But I realized, that engine's worth millions. They tied it up well. And then I backed off and said, how small is this airplane really? It's pretty small. And so now then, I come to the big day. And the day of the inspection, I have to provide a bunch of paperwork, fuel check, various kinds of things to the DAR, and another notarized statement, and pictorial evidence to prove I really was the one that did this. That's one of their big deals. And I find out that when the DAR shows up, an FAA guy shows up with him, because the FAA has chosen this day to do an inspection of the inspector. It's like, ooh, wow, okay, I hope it's good. But it goes through well, and they look through all my pictures and stuff like that, and decide that, okay, the construction looks like it was reasonably quality. And so he gives me the official 8130-7 special airworthiness certificate. And so I'm standing there beside the airplane, happy that I finally got that after 15 years of work. And I celebrated going out and taxiing around the airport perimeter. But now then, a few other interruptions. Remember, this is December 18th. Well, I've already scheduled to go back to Ohio to visit my family for a Christmas period. And so I'm not going to be there for a while. So I had negotiated with this guy originally just for be there for a week. So I had to kind of go back and say, well, I'm going to be there at least another week, right? He says, well, okay, but there's one gotcha. He says, just before Christmas, he holds a big banquet for kids. And he has to clear out the entire hangar, all the airplanes go away, and he sets up tables and all and on and on. And I said, well, okay, I'd like an airplane not to sit out in the rain, but okay, you can move it, not a big deal. So that went on. I left town. And I came back and said, well, okay, how'd it go? He says, oh, no problem, worked out great. And I went, well, what do you mean? He says, well, we just made it part of the show. It ends up that before I left, I noticed they had dozens of bicycles lined up, dozens of big stuffed bears and all kinds of stuff, and tables, all kinds of things. This is a big deal. They're giving away a lot of toys. And they ended up having a big Christmas tree and a Santa. And they ended up parking this beside the Christmas tree and said this was Santa's toy. All the others would be given away. I went, okay. So now then I have to plan for the first flight. Remember, I kind of picked 1915 because I really wanted to fly in 2015, 100 years later. So I kind of had another deadline. And December 31st is coming up real soon. But the weather's got to be right. But I also had to do flight test planning. So another handbook. There's checklists that need to be done, test plans, stuff like that. That's all good. I also want to make sure that pilot, me, is really going to be ready for this opportunity. And so some weeks back, I had already gone out and gotten some aerobatic refresher because I figure the worst thing that might happen in my test flight is that airplane ended up wrong side up, and I needed to fix it. So I wanted to practice that. I did that. I also wanted to practice a little bit with the EFIS, the controls and stuff, and I wanted to get back and get refreshed in tail wheel, because the pilots will know tail wheel flying is very different than other airplanes. So I did that kind of stuff. So I got me ready. I also had some flight advisors that gave me advice and stuff from their first flights, and I still had to pick a date, and it's very weather dependent, because I wanted to read a calm day that was clear and beautiful. And I still needed to get it done in the next few days if I could. Well, December 30th came along. That's kind of nick of time, so to speak. It was a clear day with light winds. So I taxied around as a warm-up. I did a high-speed taxi down the runway, lifted the tail. That part worked. That was good. Put it back down, went around again, did some bunny hops. Said, okay, I get off the runway. It's controllable. I put it back down the runway. Then finally went around and got clearance for takeoff and did what I tried to make a normal takeoff 3 times around the pattern. But you know, what's normal? No instrument or part on that whole aircraft ever flown before, ever been tested before. Everything there is unknown. So yeah, I was a bit on the nervous side. Did I happen to do something wrong along the way? But I planned some data collection, so I got a person to take pictures for me. I had a verb camera and video and stuff being recorded, so that was useful. I also then had an engine monitor collecting parameters. And so got the engine started on that day and was able to taxi. And there I am out on the runway ready to take off, and indeed it got up in the air and flew. So obviously that was a big thrill. After 15 years of work, it actually did fly. Got back on the ground, and surprisingly enough, it was a nice soft landing. That was the second miracle in the same day. So then came back and looked at some of the data I collected. And so there you can see I went around the loop 3 times. The bottom one was my altitude. You can see I wasn't real good at altitude control at that point, a little sensitive, so I went up and down. But I got as high as 2,000 feet, and my speed range was 38 to 68. But I did determine that I lifted off at 44 and landed at 44. That makes sense. The single biggest problem is one of those things, what do you know or what do you not know you don't know? The air noise from all the air rushing by was horrendous in my headset. And I had a real hard time talking to the tower because it was just too noisy. So that was the big surprise. So now what happens? Well, I finally found another temporary hangar after about 3 weeks in that big one. And that held me over for another month or so until the EA hangar finally freed up and I could get moved back into there. So now I had to go back and also talk to the owner of the big jet hangar. And I was so desperate, I didn't even ask him what it was going to cost me to be in his hangar. And I knew he was kind of pricey for these big jets, and I'm a little worried about that, but okay, I'm desperate. So I finally go back to him and says, okay, I'm finally out of your hangar now. I sure appreciate, the help and extensions because I was desperate and things like that. But I now need to know, how much do I owe you for 3 weeks worth of rent? He kind of says, I don't know, just get out of here. Right? So you have a pretty little toy, you go around, people are generous. Okay, so I also had an low oil pressure I had to work out and figure out that. I had a fuel vaporization issue I had to work out, an oil leak I had to work on. I finally got around to putting the color on the rudder and things like that. Got an A&R mask with a better mask, A&R headset with a better mask that helped the noise kind of stuff. Did a bunch of other rework along the way. Had to rework the muffler because sure enough, after a while, that plastic case on there began to go, right? And I realized, I think that was a display model. That wasn't a real muffler. But the fortunate part was the center part was. And so I went out and got a piece of stainless steel, bent it around, riveted in place, put it on. It's lasted great ever since. And even though you'd like otherwise, you still end up with hanger rash. I'd already had to do a repair of a wingtip. And I'd heard lots of other airplanes have cooling problems. This one wasn't any different. So first couple flights were fine when it was cool days. The third flight, it was a 70-degree day. I could see the engine was overheating, immediately landed. Started investigating and needed lots of trials. I tried with and without the thermostat. I tried fans behind the radiators. I tried using water instead of antifreeze. A whole list of kinds of things, more radiators, different radiators. I put an oil cooler in. Everything seemed to help a little bit, but nothing really solved the problem. I could still fly on cool days, but hot days, it would just start warming up. The problem was to be flying along, and level was okay, but as soon as I'd climb, the temperature would start up. I'd level off and they'd stay there. I'd climb again, the temperature would start up. I'd come back down, it wouldn't come down. So I said, enough, come back and land. but had to continue working it. And finally, basically, I had to limit my full power climb, no more than 5 minutes, kind of level cruise, monitored the coolant temperature real carefully. I was able to fly some. So finally, I realized I removed the oil cooler, removed the water pump. I added another radiator in the bottom of the cowling and made a ducts to get that through. You'll see there's modification down there where the colors don't match and stuff. So that's what I did there. And it finally seemed to solve the problem. Now, I have not been out on 90-degree days, but for 70 to 80-degree days, it's fine. So that was a big deal. So what does flight test mean? Well, you have to go out and fly a minimum of 40 hours before the FAA says you're allowed to carry a passenger or fly over a congested area. They want to make sure you know that you've tried it out. So I also tried making flight test cards, and I was going to write notes about the numbers and stuff like that. And one of the things I realized along the line is, I've got both hands full, and the wind's banging past. I can't exactly stop and take notes on a piece of paper. So fortunately, I had a microphone, and I could just voice things. So I voice recorded things on my Verb. I also had the data logging on the engine monitor, so that ended up good enough. But now then, as part of this, you have to start at minimum weight. Then you also load up a front seat with a bunch of weights and a backpack kind of thing to make sure it flies when it's heavy. You have to do static and dynamic stability tests, steep turns, and all those kinds of things to make sure that you've tested all the aspects of the input. And so basically, by the end of 28 flights, I'd really ready to start collecting data. I thought I had things under control. And I found out it was a little tricky to do good hand flying, but I was getting that under control. Flight test cards, like I found, were very useful. The data logging was the best thing. I did then 10 real test flights that collected all the data that I needed to satisfy the FAA requirements and to do things I need to know, like best stall speed, best rate of climb, best angle of climb, best glide, things like that. I never did get the airspeed calibrated as well as I liked, because the airspeed calibration assumes that you can go fly a little bit without much wind. And I never had a day out there wasn't enough wind that shifted things around a little bit. So now then, flight test is nearly complete. I'm just within a few flights. I figure, another few weeks and I'll have this wrapped up. And I'm notified that the new hangar that I fought so hard to get into, we have to vacate. So now I got the same problem again. I already know there are no hangars around, right? And some people are moving off to other airports and everything else, but it's a bit of a challenge. And so I get the final flight test logged and take care of. Got the hangar all cleaned out. I'm ready to fly back to Compton. I've got a friend out to drive my car back and take care of all that kind of stuff. I go out there for the final flight back to Compton, turn the key, and nothing happens. All right? So I was kind of discouraged that day, but went back the next day and diagnosed it and found out what the problem was, managed to fix that, finally flew the Jenny back February 27th, 2019. Now, for those that are astute with Mac, this is 3+ years after my first flight. So my flight test was kind of strung out over time. All right, but it doesn't mean I'm done. One of the things in experimental aircraft, too, is you're never really done, even when you think you are. So I wanted to add things like the leather cockpit trim and wood instrument panels, new windshields, and a bunch of things like that, and the rondelles up on the wings. Those kinds of things now are all done. You can see that. I've got a few more things I'm still working on. The cockpit headboards and some paint touch-up that still need to be done. But it's in reasonably good condition now and usable. So I did add the insignia, and they just add a lot of color pizzazz to it. Makes it look more real. And then the labeling on the side, kinds of things. So those make it look pretty. Now, a bit in summary. One of the things that's interesting here is I used all the technologies I could find. The original Jenny was all wood inside and fabric on the outside. But some of those aren't the best ones these days, right? So it ends up that the fuselage I used was welded 4130 tubing. It's stronger and sturdier to make safer in the long term. Wings end up being riveted aluminum. So made the spars out of aluminum tubing and then leading trailing edges out of some bent aluminum that I had to fabricate myself, that kind of thing. I did then use fabric covering because it's still actually, interesting enough, fabric covering is still a modern construct technique if you use the right stuff, like the Superflight fabric and the right fabrics and dopes. One of the things that was the biggest problem back then was that the head paints that sort of worked was called dope and fabric. The problem with that is that dope was really flammable. And if there's any kind of a spark or flame anywhere near, your whole airplane just went poof. Where nowadays they have fireproof paints and stuff that are a lot better. So the struts I had made out of Douglas fir, because that was a good wood for that. And you notice I even managed to find some really straight grain wood that was high quality. And I found out they don't go into a lumber yard and just ask for regular wood. Ask for stair treads. They do cherry picking, and they save their best wood for stair treads. So that's where I could find that and cut it up and got that to work. Cowling then needed to be various shapes. Part of it's aluminum, part of it's fiberglass. Cockpit trim was a combination of foam and leather and things like that. The instrument panels, as you can see, a combination of round dials and the EFIS. And then everybody asked, well, how long did it take you? And the answer was, when I quit logging the time, it was over 6,000 hours. By the way, the plan said you could build it in 400. I figure that was the designer building his third airplane. He could do it in 400 hours. And I agree, the next one, if I built such a thing, which I probably won't, I could do it in less than 6,000 hours. But I had to learn some stuff along the way. So there was the effort over 17 years. You can see the biggest amount of effort was on the engine and wings, not too surprising because those kind of things had lots to be done. So I fit 1,500 days overall, over 6,000 hours. But you don't build this because you're in a hurry to get it done. You build it because you like the challenge, you want to learn things along the way, you want to do a good job, you want to prototype, reverse engineer, try this, try that. You like puzzles, you like engineering, then you like building an airplane. The other thing everybody asks me is, what's the cost? Well, I got the engine and fuselage given to me, so that didn't cost me anything. I don't know how much it would cost for that, right? I had a bunch of other donated parts, like a muffler and other kinds of things, so I don't know what that was. The actual parts that I bought myself and put in, I kept all this stuff, and that was around $18,000. Supplies, tools, and various things like that, I spent a bunch more money on. But notice that was nothing compared to the hangar space. It ends up maintaining the hangar for, 16, 20 years? At $500 a month or whatever, kind of thing. That's ended up being where the expense is. So it's not the parts that you put in the airplane that's the problem, it's the other stuff. And that wasn't even, I didn't even pay for the hangar to begin with. I paid for it partway through, so how much does it overall cost? I don't know. Lessons learned. Use a really good table to build the wings. The accuracy of that is super critical. Expect to make prototypes, try it, cut it apart, build something else, try it again. In order to make good parts, you need some good jigs to hold everything square and straight. The building gets addictive. After you do it for a while, you want to keep going, keep trying more and more. Even when you think you're done, a deadline is really hard to meet. After the first flight, you're not done. You still got lots of things to do. The first flight airplane is already going to have hangar rash. That was kind of frustrating. Cooling is always a challenge. I had to learn many new skills, but that's part of why I liked it. The flight test data collection is hard, but I figured out a way of managing to do that. And overall, it's a really good excuse to buy tools. And just because you're done, you still got to buy more tools. One thing I should need to go back to, I talked about this. At first, I was only doing work on Saturdays and working during the normal part of the week, and later I got to do some weekends. And so it was taking up a lot of my free time. And when I first was explaining to my wife, Vicki, how I was going to do this, she was kind of saying, you're telling me that you work 5 days a week plus when you're not traveling. You're going to be working on this every Saturday. When are you going to be home to do other kinds of things? And I said, well, okay, we'll have to see how this is going to go. Well, after a couple of months go by, I haven't heard any complaints particularly. And so I go back to her and said, well, okay, I'm spending a lot of time on this. How's it going? She actually says, it's okay. I went, really? What's what? She says, when you come home, you're in such a better mood, it's worth it. Okay, so other things people ask is, how can you get started? Because everybody out here now wants to go build their own airplane from plans, right? Want to do that? Anyway, first thing you do is join Experimental Aircraft Association. For anybody that hasn't heard of that, EA.org, they're really the master organization about building aircraft. There's a handbook kind of thing called Aerocrafter that talks about all the different kinds of plans and kits that are so you can look through there and figure out what you want. Even though I didn't do that, because my airplane found me instead of me finding it. There's an EA Sport Pilot information. There's things like hints for home builders. There's hundreds and hundreds of videos now, just short videos online that are great. If you want to know how to do this or that or whatever, there's probably a little video in there that shows you how to do it. So it's really helpful. There's a magazine also addresses a lot of that called Biplane. One of the biggest problems if you're trying to start new is there are so many different options for plans and kits and things like that, that the amount of time it's going to take you to build it varies widely, and the amount of money you spend on it varies widely, sort of in between, opposite ends, right? You can actually get things that are quick build kits, you pay more for them, but then it doesn't take so long, vice versa. So lots of choices there. Fortunately, there's also lots of free advice from other builders. You get in an EA group or something like that, and they will help a lot. And I depended on calling up friends and asking them, okay, how do I do this? And I always seem to find an answer eventually that helped me move on. Okay, thank you for listening. This is actually after my plane was built out at Chino, and I'll be glad to answer questions. Yes?
I didn't hear what you used for the wheels, the wire wheels.
Question was, what did I use for the wire wheels? Fortunately, somebody had given me those, so I didn't have to make the search for myself, but what I found out was they were from a hot dog cart. You ever see a big city like New York? They have these little hot dog stands, like a tricycle somebody rides around. It's a heavy cart on that, right? These wheels and brakes are off of that. Good question. Yes? Okay. This was an Ivo prop. It's ground adjustable. It's composite, you can see. Why did I pick that one? Because I was fortunate enough somebody gave it to me for free. Now, that's one thing I want to do as far as the propeller goes, is I want to buy a nice wood scimitar that'll look real cool, but it'll work a lot the same. Other question? Yes?
Was a 65 horse air-cooled engine a solved all your heating problem?
I have no idea. He wanted to know if a 65 horse air-cooled engine would do better. On large airplanes, air cooling doesn't solve the problem because now then you have to worry about all the airflow over the cylinders, and that ends up being uneven cooling. In general, on commercial aircraft, most water-cooled engines are easier cooling problem than the air-cooled ones are. But that's what I had, and so I just had to figure out what it was and solve the problem I had. Next question. Yes, Peter? I guess it was the one out in Riverside, because that's where I was he asked which FISDO I worked out of. So I worked out of Chino, or Riverside, because it's near Chino. Other questions? Yes?
I'm curious how or if you were able to determine some of the...
He asked about how I determined parameters like weight and balance, center lifted kinds of things. The design, of course, has a range of options that are allowed for the center of gravity, given that wing fuselage combination. So you start with something like that. It also gives you things like what your max gross weight is. It warns you to keep your empty weight down as much as possible by don't put anything on there you don't have to have, as in the airplane. But then ultimately, when you get it all built, you put it on scales and you weigh it. And you figure out what the total weight is, and then you figure the weight of the tail versus the weight of the main wheels, and you can calculate where your center of gravity is. And I was within the allowed range, and so it was okay there. So basically, you start with the design, and then you make some measurements to verify that indeed that is okay. Good. Yes?
Where did the airflow come from? Was it scaled down from the original?
Okay, good question. He asked, where did the airfoil come from? This designer did a number of things that helped builders make it easier. He picked standard sizes of things. So you never went, say, beyond a 4 foot by 8 foot sheet of things, because a 4.5 foot wide sheet is something, really painful, right? So he did good at that. He also wanted a more modern airfoil and looked around and found out there was something called an Easy Riser Ultralight. It was about the same size. And he found out that that Easy Riser Ultralight had pre-pressed ribs you could buy. So he specified that rib plan for him and then told you how you could either make your own ribs or just go buy a bunch of those to save time. So that was...
Is there a gear reduction on the prop?
Yes, there is. It's a Hirth gear reduction. He asked about the gear reduction on the prop. The engine, for an automotive engine like this, turns around 5,600 RPM, which is way too fast for a propeller. So I had a Hirth 2.54 gear reduction. So it basically reduces the prop speed down doing the 2,000 range, which is much more reasonable for the aircraft. Yes?
Did he have any engineering knowledge before this started?
She asked if Vicki had any engineering knowledge of this. No, I think she just covered her eyes and hoped. Okay, one more question. Ran out? No more? Yes? No. Actually, slight modification. I took a bungee cord and I wrapped it around the front of the seat. But it doesn't work very good. There's no spring, there's nothing official. Like I said, there's a bungee cord I can adjust a little bit to help a little bit when I'm flying. Okay, thank you everybody for coming, and now you're welcome to come and ask me questions here, or we'll go out and point and look at the airplane. Thank you, Bruce.